And let's first go over the schedule. We're going to go over homework problems, review last class material, do some more on parabolas, and then do some practice problems. So let's begin with the first homework problem. So hopefully people did this. And find the center and the radius of x squared plus y squared minus 4y plus 4x is equal to -4. So I'll give you a couple moments to do this, and then we can go over it. All right, let's go over this. So do we have a couple of answers? Yes, William. William, how did you solve this?
So first I have to turn this into like the normal equation, which is I think
Which
x, I think it's x minus h squared plus y y minus k squared equals r squared.
Okay. So the
And
solution is going to be in this form, right?
yeah. Yeah, but we can't have to get turn this equation into the that format. So I just first combined all of the x's and all of the y's together. So x squared plus 10x plus y squared minus 4y equals -4. And after that, we have to complete the square. So, in order to complete the square, the for the x squared plus 10x to complete the square, we have to add a 25. So, x squared plus 10x plus 25 plus y squared minus 4y plus 4. And we have to add 25 and add the 4 to both sides, so it is equal to 25. Yeah, and after that, we just factor it. So it becomes x plus 5 squared plus y minus 2 squared equals 25. And then is based on equation, the center will be hk, which is -5 2, and the radius will be 5.
Very good. So center is -5 2, right? And the radius is equal to 5 because this is r squared. So you square root it. So if you do want to graph this, you can. You find the center first. So to the left, 5 up 2, that's the center. And it so happens that the radius is also 5. So there's going to be a point here. If you go 5 more to 10, there's going to be a point here. And a point here. You can draw your little circle. That's basically the circle, right? And the radius is 5 here. Okay, very good. So let's go number 2 and graph the parabola x squared is equal to -16y. So I'll give you a couple moments to do this, and then we'll be back. All right, let's do this one. Okay, so who can volunteer with this? Okay, William again. Okay, William, let's do this. So first of all, let's review. This one is of the form x squared is equal to negative 4py. So William, what exactly does that kind of parabola look like? What direction does it open to? And yeah,
Yeah.
where's the
It
center?
goes it goes down.
Right, it goes down. So it's like a downwards parabola, pretty simple, right? So now let's actually graph this parabola. So first we have to find p, right? We find p first. So what is p? P is
And
equal
P is
to
4.
4 because you basically compare 4p, negative 4p is equal to negative 16, you get this, right? And the center, of course, is 0, 0 because that's what we learned. We didn't learn anything else. So it's 0, 0. And so the center is here, right? And
Yeah.
P is 4. That means the focus will be left, right, up, or down of the vertex.
Down.
Down because the whole parabola is shooting down, so the focus is going to be in the direction the parabola is in. But there's also the directrix, which is in the opposite direction here, and this is just x is, well, no, y. Y is equal to 4 here. And this is our focus. And we have about this kind of parabola. So, are there any questions? If there are no questions, then I will continue. So we have another question about a parabola here. So write the equation of a parabola with vertex at 0, 0 and focus at 0, 3, 0. Then sketch. So I'm going to give you guys that didn't do this one a few moments to do it, and then we'll go over it. All right, let's do this problem. So who can volunteer to do this problem? Someone else this time. How about Grace? Grace, can you solve this
Oh,
problem
sure.
for us?
Okay. Okay, so since the focus is at 3, 0, it'll open to the right. So then the directrix will be at -3, 0. So it should wait, do I have to sketch it?
We'll sketch it later. First, tell me the equation.
Okay, it'll be y squared. It'll be y squared equals, let me think.
Well, the original
12.
equation is y squared is equal to
Y squared equals to 12.
there you go.
No, wait, no. Wait. Okay.
Is it not 12?
Wait, let me think. Yeah, it's y squared equals to 12x, I think. Yeah.
Yeah, because it's for px. First, you have to find p.
Mm.
Whenever you find p, you can find the equation because p is the distance from the vertex in the focus and the vertex to the directrix. That's obviously 3. You put it into the equation, then you obviously have this equation. So if we graph, you're right, it does open to the right. And as you can see, this line is x is equal to -3. This is the focus here. And this is basically what it looks like, right? And if you take a point on this graph, it should the equal distance from here to here. And obviously my graph isn't exactly equal, but you get the point, right? So I'm not exactly looking for accuracy when you sketch this. Like it's not very precise sketch. It's just ballparking, I guess. But you have to make sure you know the equation. So the equation is the big part. So let's review a little bit on circles, right? Quick review, basically what we did last class, and then we can go a bit more into parabolas. So since we've already learned this, I'm going to ask some volunteers or anybody in the chat to tell me what these things are. Right, so can anybody in the chat tell me what is the equation of a circle again? So everybody should know this. What is the equation of a circle? So somebody type in the chat, right? What is the equation of a circle? Okay, very good. Yes. So the equation of a circle is x minus h. X minus h squared plus y minus k squared is equal to r squared. So the way we get this is through the distance formula, where of course center is equal to hk. So speaking of the distance formula, what is the distance formula? Okay, so what is this distance formula? So who can tell me what the distance formula is? Which is basically the distance between 2 points on a graph, right? 2 points on the graph. So you can find it if you draw a triangle. You use the Pythagorean theorem. So what is the distance between 2 points? That is the distance formula. So the distance formula is going to be equal to d squared is equal to x2 minus x1 squared plus y squared minus, no, y2 minus y1 squared. So then d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So obviously, if you want to look at this, you see the distance here. Let's make that a segment, and you draw this imaginary triangle. This distance is obviously y2 minus y1, and this is x2 minus x1. By the Pythagorean theorem, which applies to all right triangles, which you can draw for every 2 points on this coordinate plane, you can draw a right triangle. So this applies to any 2 points, and for every right triangle, you can use the Pythagorean theorem to find the hypotenuse. And basically, the distance is the hypotenuse. So here we can find it like this. And finally, the midpoint theorem. Not the midpoint theorem, it's midpoint formula, right? Midpoint formula, we're finding the midpoint coordinates between 2 points is going to be x1 plus x2 squared and y1 plus y2 squared. So this is pretty obvious, right? You take the average. You take the average of these 2 points, right? So that's pretty self-explanatory, right? So this is our review on circles, and of course, the way you find circles is also pretty easy. So if I draw a graph here, and I use the distance formula. So for example, our circle is like this. Let's just say this center is HK, even though obviously it is at 0, 0. Let's just say this is HK. This is some arbitrary point P, X, Y here. And of course, this is R. And this is our right triangle. Obviously, using the distance formula and the hypotenuse, to find the hypotenuse, we use this distance formula and the Pythagorean theorem. So then we get x minus h squared, which is this side, and then this side is plus y minus k squared is equal to r squared here. And we don't square root it because that's kind of inconvenient. So we just leave it all squared. So that is the review on circles. Now let's go over our new definition of a parabola again. So let's go over that. And that is basically the set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix. So I'm not going to write all of that down again, but I'm going to draw you a graph so you get it. So it is the set of all points on a plane that are the same distance from the focus and the directrix, and the same distance is very important here. So we have our vertex here, and I'm just going to say the vertex is going to be 0, 0, and we have a parabola, or what is going to be a parabola. The vertex is always in the direction of where the parabola opens. For example, let's say your vertex is at 0, 0, and the parabola opens up. then the focus is going to be something like 0, 2. It's above the vertex because it opens up. If the parabola opens right, then the vertex is going to be left of the focus is going to be right of the vertex, right? If the parabola opens left, then you get it, the focus is going to be left of the vertex. So that's the focus, right? And that is going to be, in this instance, it's going to be 0p, right? And the directrix is going to be y is equal to negative p. Basically, it is a set of all points, right? Such that the distance from the focus here and the directrix in the perpendicular direction to the directrix is the exact same. So obviously we can start to see a couple of points here where the distance is pretty similar. So, and you can also do just one side because obviously it is symmetrical. So if you get a point like this, right? So this is basically what it looks like. And you also have this here. Okay? So of course these are equal distances. Okay. So then all you need to do is you need to draw a curve through these points. Right? And that's your parabola. Obviously this isn't the best parabola, but you get the idea. The distances are the exact equal. When I need you to graph a parabola, I'm not really looking on the very specific accuracy of this. You can always do this by checking, by graphing using a table of values, plugging in points for x and y, but the most important thing is to know the equation of the parabola, not just very precise graphing here. So I don't really care that much about the graphing as long as it's very similar, and because we're just ballparking here. So that's basically the new definition of a parabola. Of course, it also has an axis of symmetry down the middle here, and it looks just like a regular parabola. It's just a different way of expressing a parabola. So that's the difference. So I'm going to give you guys a couple minutes to see if you remember all the formulas for the parabolas. So type in the chat. And try to list all the general formulas for the parabolas, right? And you also gotta state them. Like state, for example, this formula is for when the parabola has vertex 0, 0 and opens right. Or maybe this formula that you remember is the parabola opening left. So put all the general formulas that you remember in the chat here, and then we'll go over each one. Okay, let's see these. So Grace said y squared is equal to 4px for opening right. Negative 4px is for left. 4py is for up, and negative 4py is for down. And that's correct. Okay, so let's do this. Of course, we have 4 situations, right? When it opens up, when it opens down, opens right, or opens left. So here's here's all the graphs. This is opening up, opening down, opening right, and opening left. Right? So these are all the possible things we can have. And this one is going to be x squared is equal to 4py. So this is the most normal parabola we know, right? Because earlier, before you learned this last week, x was always the one squared, right? Of course, it's y is equal to x squared, right? So of course, when it's negative, it's gonna open down, right? And that same logic applies to when it opens right or left. But when it opens right or left, x and y are switched. So this is going to be y squared is equal to 4px. And this is y squared is equal to negative 4px. Right? When it's negative, it opens down and left. Pretty straightforward, right? Self-explanatory. So that's the general formula for all of these. And of course, this is the vertex in all of these is 0, 0. We haven't done any modifications to the x and y yet. It's just y squared and it's just x squared. We haven't done any modifications whatsoever. And modifications are what we're going to talk about today. Modifications to these parabolas. So we now have, in general, let me just say this. We now have a couple different formulas now. So this is when the vertex is moved, right? P basically controls what the parabola looks like how slim it is, how wide it is, right? So basically, usually when P is big, it's pretty wide, and when it's small, it's pretty slim, the parabola. So, but how do you change the actual position of the parabola? You have to change the vertex. So in this case, we set the vertex is equal to hk, it's no longer 0, 0. And it's actually pretty easy if you think about it. We just modify it just like the circle, right? The vertex here. So if we have vertex hk, it's going to be x minus h squared is equal to plus or minus 4p over y minus k. And this is going to be for when it opens up or down. We also have y minus k squared is equal to plus or minus for P, x minus h, right? You switch them. You switch the variables. So this is when it opens up or down. This is when it opens left or right. Okay? So the focus here is going to be h and then k plus or minus p, right? Or h plus or minus p, k, and then the directrix changes accordingly to y is equal to k minus p, or x is equal to h minus p. And of course, the axis of symmetry is equal to x is equal to h, or y equal to h, or y equal to k. But an easier way to think about it is like so, and I'll show you in a second here with this example. So first, I want everybody to try and attempt this problem first. Right, the equation of a parabola that has a vertex at 2, 6 and a focus at 1, 6. All right, let's go over this one. So let's choose someone who can do this problem. So who wants to volunteer to do this problem? How about Brendan? Brendan, can you do this problem?
I think so. I'm not sure though.
Okay, that's fine. But I'll help you through it. So first of all, we know that, let's just draw the coordinate plane real quick. So Brendan, look at this. We have a vertex at 2, 6, right? This is the
Mhm.
vertex. And the focus is at -1, 6. So remember how I said where the focus is where it opens up, right? So if the focus is at the left of the vertex, does the parabola open left or right?
I think right.
It opens left
Oh.
because the focus is at the left of the vertex. So obviously it's going to open left, right? And we do know our equation for when it opens left. When a parabola opens left, it's going to have the equation. It's going to have the equation y y minus k, where it is equal to -4p x minus h. So Brennan, the vertex is 2, 6. So then we know that we plug in 6 for k here. So Brennan, what is the same for h? What is h here in the vertex?
2.
Very good. So we substitute 2 in for that. And then finally we need p. What is p? It is the distance between the vertex and the focus, right? So what is the distance between the vertex and the focus?
1, I think.
1.
Wait, no, sorry.
What is this distance? From 2 minus -1, what is that?
2.
2 minus -1
Oh no, 3.
is 3, right? So p is equal to 3. So we sub that in, we get -12. We get -12 x minus 2 here. So that's very good. Okay, so that's basically it for finding the equation. So now if you graph, you have okay, so we have this. Right? So then we have something like this because the directrix is over here. Okay, so that's all for this problem. Again, you don't have to be too precise with the graphing. Just make sure you have it pretty accurate. There, we're just ballparking. Okay, so let's do the second one. Okay, let's go over this one. So find the opening direction, vertex, axis of symmetry, the focus, and the directrix. So obviously the opening direction here, if we just look at this equation, is up. So we're opening up here. P is going to be equal to 3. So the vertex, before we do anything, is going to be 3, -2 here because of these. The axis of symmetry, right, is going to be x is equal to h, which is x is equal to 3, right? So then 4 is going to be equal to the focus, which is 3 so the vertex is 3, -2, and it opens up. So it's going to be 3, -2 plus p. So that's 3, 3, 1. And the directrix is going to be at x. X is equal to, no, not x. It's going to be y. Y is going to be equal to k minus p. So it's 2 minus 3, which is -1. Okay? Actually, no, that's actually incorrect because the formula was incorrect. The directrix here, because the vertex is at 3, -2, and it's going to be 3, 1 for the focus, then it's 3, -5 here. It's 3, -5. So it depends. Y is equal to -5. So the directrix in general case could be P minus K, P minus K, or Y is equal to K minus P. So make sure you're careful. So always draw this, right? Always draw this. So our last one here. Let's just find a volunteer to do this. So who wants to volunteer to do this? How about Grace? Grace, can you do this?
I don't think so, but I can try.
Very good. So we can try, right? So first of all, is this in the general form?
Wait,
No, right?
no.
So how do you get it into a general form?
You have to
Complete the square, right? Complete
Yeah.
the square.
So
So help me complete the square.
it would be
So let's just move
it's
things
y
to
squared.
something, right?
Okay. Wait.
So obviously it's going to be y squared is equal to 4px somehow, right? So obviously x is on one side, y is on one side. So let's just move things. Move x to this side, right? It's going to be 4x
Plus minus 1.
minus 1, right? It's going to be minus 1. So then to complete the square, we know that y squared plus 6y plus 9 is equal to y plus 3 squared. So we need to, so what do we need to do to complete the square here? We already have two components.
We need to include the
What are we missing?
we're missing the x. I don't know. The 9 from the equation.
Yes, the 9.
So
And how are we going to get that 9?
we have to half we have to half the 6y and then square it.
That's right. But how do we get it into this equation? We add it, right? We add 9 here. So then we get y plus 3 squared is equal to 4x minus 1. Is that correct?
Yeah.
Are you sure?
No, we have to
Because
add 9 to both
when
sides.
you add 9 to this side, you have to add 9 to this side too, right? So you can't just add 9 to one side. So make sure everybody remembers that when you complete the square, when you add a constant, you have to add it to both sides. So then essentially you get y plus 3 squared is equal to 4x plus 8 here. So y plus 3 squared is equal to 4 times x plus 2. So now it is in standard form of y minus k is equal to 4 x minus h. So you're pretty good with formulas, right? So what direction does this open up in? Can you tell me?
This one opens up in, wait. It opens up to the, wait. The right? Because, wait.
That's true. It
Yeah.
opens up to the right. So obviously we can list out the answers now. It opens up to the right. So what is the vertex? If the vertex is HK, what is the vertex here? There's a vertex.
Vertex is 2, 3. Oh, no, yeah, 2, 3.
Are you sure?
Wait. Oh, wait, no. -2, -3. I was
Okay,
thinking.
-2, -3. And the axis of symmetry, don't worry about it. We don't really need that. It's just whatever. So, and the focus is important. So what is the focus? First, we need to find P, right? P, obviously, here is 1, because we compare 4P is equal to 1, 4P is equal to 4, P is obviously 1. So, since we're opening right, the focus is to the right of the vertex, and that changes the x value. So it's going to be -3, -3. That is where, no, that's false. It's -1, -3, because it's the right of the vertex, right? So that's the focus, and the directrix is going to be the left. So it's going to be at x is equal to -3. Okay, so that is how we answer this question. There's going to be similar problems on the homework, which I already posted. So make sure you go look at that. And that's all for today, actually. So I hope everybody took notes and understood. And I'll see you next week.